Hey guys, what is up? Hope all of you are doing absolutely fine. I am Parikh, working as a software engineer in a product-based company and having around 3+ years of experience in the IT industry. So in today's video, we'll be solving a really interesting question which has already been asked in many big tech companies as well as top product-based companies, including Microsoft, Google, Amazon, Uber, LinkedIn, and many others. So yes, we are going to learn a lot of things today, not just the solution, but we'll be looking into how should we approach to a problem whenever asked in our interviews, whether be it a machine coding round or a coding interview where you have been asked to solve a DSA question. So our main focus is not just the solution, but how we are approaching towards a problem, how we are thinking logically, especially for beginners when we are just figuring out how to solve DSA problems and improve our logic building skills. So yes, let's jump to the problem statement. As you can see in the screen, the problem statement is contains duplicate. So it's not that simple one that if there are two duplicates in an array, we'll say that array has duplicate numbers or strings. Okay, it's not like that. Let's understand the problem. So let's say you are given array of integers and an integer k, which is 3 here, for example, and the nums array here is 1, 2, 3, 1. So now what we have to do, we need to check few conditions and based on that return whether this array has a duplicate value or not. What are those conditions? Let's look at it. So consider I and j as distinct index. So what are indexes? Basically, if we want to access elements from an array, we use indexes. So here there are two indexes I and j which are distinct, not same. So if nums of I is equal to nums of j and absolute value of I minus j is less than or equal to k, if these both conditions are being satisfied, then the array contains the duplicate. This is the problem statement. For example, let's look at this. Index here would be 0, 1, 2, 3 and nums here is 1, 2, 3, 1. K here is 3, right? So as you can directly see, here 1 and 1, this both are same, correct? And index is 0 and 3. So what was our condition? Absolute of I minus j, that is 0 minus 3, which is minus 3, and the absolute is basically the positive value, which is 3. 3 is 3 less than or equal to k. What is k here? 3. Yeah, so 3 is basically equal to k and which satisfies this both the conditions, right? So in this case, we'll return true, correct? Let's take another example. Basically here, there are multiple possible values, right? As you can see here, I can be 0 and j can be 2, which means this and this, the number is same, right? Then it can be 0 and 3, which is this case, 0 and 3, right? In that case also number is same. And the third case is 2 and 3, this and this. Even in this case, the number is the same, correct? But let's check the I minus j thing. Here I minus j is minus 2, minus 3 and minus 1 respectively. Absolute value is 2, 3 and 1. And whether is it less than or equal to k, first and second is false, last one is true. So at least if 1 is true, we will return true, else false. Clear? Let's take another example. Here nums is 1, 2, 3, 1, 2, 3. So total 6 elements and k is 2. So possibilities of same elements are this: 0 and 3, 1 and 4, 2 and 5. 0 and 3, 1 and 4 and 2 and 5. All have same elements: 1, 2 and 3. Correct? Now let's check the I minus j thing. What is here? Minus 3, minus 3, minus 3. Are all less than or equal to k? No, right? So result will be false. Is at least one value true here? No, right? So we'll return false. Understood? The problem statement is clear? Great. Awesome. So now what we need to do, we'll not jump directly to coding, but we'll see how we can solve this with the most straightforward approach. That is the brute force approach. Now this is important. Whenever you are solving a DSA problem, and if you are a beginner, start with the brute force approach. Why? Because we don't need to overthink much right now as we usually do for some things in our day-to-day life. We just need to simply apply the brute force approach. I also call it as a straightforward approach. Whatever comes to your mind, apply that. In this approach, we don't need to worry about what is the time complexity, what is the space complexity. We are just trying to approach the problem. Okay? So do this as the first step. Most important. So in this case, what would be the brute force approach? We'll take this as an example. And one more thing I would like to add before discussing the approach, that whenever you are trying to build an approach, start with the examples provided. That will help you to think clearly. And then you should go with the brute force approach. Okay. So here we are taking this example, which is nums 1, 2, 3, 1 and k is 3. So what we'll do here, we need to compare each and every element, right? So 1 we will compare with 2, 3 and 1, right? And 2 we will compare with 3 and 1, and again 3 we will compare with 1. Only then we will be able to determine that whether the conditions are being satisfied or not, right? So what we'll do, we'll have to traverse the array from 0 to 3. So in each iteration we'll take the elements and compare it with the other elements, right? So we will need here 2 for loops. Why? What would be the role of first for loop? It will be used to iterate every element, right? 1, 2, 3 and 1. So let's say when index is 0, we have the element 1. So now we will compare 1 with 2, 3 and 1. So we'll also need another loop which will traverse through 2, 3 and 1, right? And then we will check that whether the elements are same and the other condition is being satisfied or not. Okay, so what would be our algorithm here? We'll iterate through outer loop, which I have called here as L1, and we'll iterate it to 0 to n minus 1. Why 0 to n minus 1? Because our last iteration would be 3. We don't need to compare 1 with any other value. Our last comparison would be 3 and 1, right? So we'll always go with 0 to n minus 1. And we'll also take an inner loop, which I've called it as L2, and that will be I plus 1 to n. Why I plus 1? Because if our I is 0, we need to compare with other 3 indexes. So we'll start with I as 0 and j with I plus 1 to n. Understood? Awesome. Then what we'll do next? We'll do comparisons and check whether the condition is being satisfied or not. Clear? So if we see this, our L1 loop, that is the outer loop, will go from 0 to n minus 1. Our inner loop will go from j equals to I plus 1 to n. And then we'll check the condition whether absolute of I minus j is less than equal to k and nums of I is equal to nums of j, which is the value comparison. And this is the indexes comparison. So if both these conditions are being satisfied, we'll say that we have found the match and we'll just break the loop. And in the outer loop, we'll check if match has already been found. We'll also break the outer loop and return the flag, which is either true or false. Okay. So let's say our first iteration is I is equal to 0. What is nums of I? Basically the first element, which is 1 in this case, correct? And our inner iterations will be j equals to I plus 1, that is 0 plus 1. So basically j is equal to 1 and nums of j is 2, which is the second element, right? What is the second element here? 2, correct? So our first inner iteration would be this case. Our second iteration would be this case. And our third iteration would be this case, in which we'll have the match 1 is equal to 1. And now we'll see 0 minus 3. 0 minus 3 is minus 3. Absolute value is 3. Is 3 less than or equal to k? What is k here? 3, right? So yes, 3 is less than or equal to 3, which satisfy our condition, and we will return the result as true. Understood? So this is the brute force approach which we have applied here. And if we try to run this, let's see what we get. So this is the code as you can see here, and I will use JavaScript as the programming language. You can see we have taken the first loop from I is equal to 0 to nums.length minus 1, which is the second last index. And our inner loop is j equals to I plus 1 to the last element. Okay. And we have just added a check here. If I minus j is less than equal to k, and if nums of I is equal to nums of j, match found equals to true. Initially match found is false. If match found is true, we'll just break the inner loop and then the control goes here. If we have found the match, just break the loop and we are returning the result here. Okay, let's execute this for the sample test. So you can see all our sample test cases have been passed. Awesome. So now if we submit this solution, we will see a detailed test running. Oh, and as you can see here, we got the error time limit exceeded. So what does this mean? That our solution is partially true, but not completely. Why? Here comes into the picture constraints. So what are the constraints here? Basically, these are the limitations we can say which needs to be satisfied when we are writing our code. Okay. So here the length of the nums array would be from 1 to 10 raised to 5. And the elements, that is the values inside the nums array, would be minus 10 raised to 9 up to 10 raised to 9. Okay. And k can be 0 to 10 raised to 5. So we need to consider these constraints as well whenever we are trying to build our logic. So now we know that our solution is partially true not completely. We will modify it in such a way that it satisfies our constraints. So now we know in some cases the time limit is getting exceeded. In this scenario, the num's length is, I think, a lot more, and the value of k is 612, which means that it is taking much more time than it should. So now we know that we need to do something in order to pass this test case and also to satisfy our constraints. So what we'll do next? So basically time limit is getting exceeded just because we are performing more number of iterations than required, right? And here comes the time complexity. If we see in this case, the time complexity for outer loop is O of n, right? Why? Because we are performing n number of iterations from 0 to n minus 1, which is basically O of n, right? And the inner loop is also taking O of n. Why? Because it is also going from I plus 1 to n. We are considering here the worst case complexity. So in total, it will have the time complexity of O of n square, right? So now we should think accordingly that whether we can reduce this time complexity. Is it possible? Let's check that. So let's consider this same example. Nums is 1 2 3 1 2 3, k is equal to 2. So now here we will use object, which is also known as map or dictionary in other programming languages, right? So what is basically an object or a map or a dictionary? It's just a pair of key and values, which can be written as key 1, value 1, right? And why would we use this? Because accessing values from an object just takes a time of O of 1. So how would we modify our solution? We will of course need one for loop to traverse all the elements, right? But whichever element is being traversed, we'll keep on storing them in the object. That is, let's say we have traversed the first element, which is 1, right? So what we'll do, we'll store 1 as the key and the value will have the index, right? So what is the index? 0. Next, we will traverse 2, we'll store 2 as the key and 1 as the value, which is the index, right? Next, we'll store 3 as the key and 2 as the value, which is the index. Now what would be the next element in our iteration? 1, right? Which means that this is the same element. We don't need a separate comparison whether nums of I is equal to nums of j. So now if any element coming up again, we just need to compare the object value. For example, in this case, when 1 is coming up again, we know that what was the last index from our object value. So 0 was our last index, right? So now what we'll do? So we'll just subtract 0 minus the current index. What is the current index? 3, right? So is 0 minus 3 less than or equal to k? What is k? 2. No, right? In that case, we'll just update the index as 3. Okay, so next time if 1 is coming up again, we'll have the latest index to compare it with. Correct? Now let's say 2 is coming up. What is the index of 2? 4. So in this case, object value of 2 is 1, which is the latest index, and the current index is 4. 1 minus 4 is minus 3, right? Absolute is 3, which is less than or equal to 2? No, right? Similarly with 3. In this case, the latest index is 2 minus the current index 5. Result is minus 3. Absolute value is 3. Is 3 less than or equal to 2? No, right? So this condition is not being satisfied. Hence we will return false, right? So what would be our updated algorithm in this case? We will traverse from 0 to n, and then we will check in each iteration whether the array element already exists in our object. If yes, then we will do the comparison, which is absolute of I minus j is less than or equal to k. If that is being satisfied, we will say we have found the match and break the loop. Else what we'll do, we'll just update the current index as the latest index in our object, as you can see in this step. Okay, and what is this? So basically, if the array element does not exist in our object, then we will have to add that element in our object, right? So next time it comes up again, we can check this condition, right? So basically, in both these cases, we are doing the same thing. So we can also remove this and just add it once here outside our if block. This way, right? This will give the same result. So now let's try this solution and check whether it's passing all the test cases or not. Here first I've taken an empty object, traversing from 0 to last index, then checking whether the element value already exists in our object. I've used this isNaN function here basically to check whether it's a valid number or not. Because if I don't use this, it might be possible that the value is 0. When would this happen? When our index is 0, right? So in that case, it won't execute this if block. So yes, the value is already present. We'll make this comparison, and if it satisfies, we'll say we have found the match and just break the loop and assign the latest index or the value to our existing element in our object, right? And we will finally return the result here. Let's run the sample test cases first. Okay, now let's submit and run all the detailed scenarios. Awesome. So our solution is accepted, as you can see, and runtime is just 94 ms, and we didn't get time limit exceeded error this time, right? So yeah, I hope you really now know how to approach towards a problem. Of course, solution is not important every time, because in coding interviews, interviewers would be more testing your logic building skills, how you are reaching to the solution step by step. And now you know what you need to do and where you need to start from. Start with the brute force approach first, and then try to see where you need to optimize it. Also, the more and more you practice, the more logic you will be able to build. So yeah, that's it for the video. Keep learning and keep practicing.